So let's see the implementation of the problem, unique number 3. So yeah, the input format says you're given n followed by n numbers, and this time I won't be creating an array, and I would be directly updating my sum array, right? So we have seen how you can build this sum array. So this array is of fixed size, that is 64, and what we can do, we can read the first number and we can directly add the contribution to the sum array without storing this number. So we can say, okay, the first 0th bit makes this as 1, this bit makes this as 1, this bit makes this as 0. Next time you read this number, so this sum array becomes 220, right? So finally, once you have read all the numbers, you will get this sum array as 640. So remember, in the explanation we stored in this order, but while implementing I'm going to store in this order. So the contribution for the 0th bit will come at the 0th index in the array, and the contribution for the 64th bit will come at the 63rd index in the array. Okay, so this is how we are going to implement this one, right? So yeah, let's start by writing in some code. Okay, so first thing that I need is to make a count array, and it will be initialized to 0, and then we need to iterate over n numbers. So we will read n, and we will put a loop here. Okay, let's read the number. Number. Then what I will do, I will update the count array, okay, by extracting bits. So let me declare a variable j which is 0, that denotes for the number we are going to extract the 0th bit and store it at the 0th index in the array. And we can say while this number is greater than 0, we find out the last bit, okay, and we can say count of jth position plus equals to the last bit. So if the last bit is 1, we will update the jth index of the count array by 1, otherwise we will update it by 0. So last bit is given by number and 1. So we can say count plus equals to last bit. And for the next position we can increment j, and to get the last bit for the next position we have to right shift the number by a factor of 1. Okay, so let me just tell you what we are doing here. So suppose you got a number 5, so 5 is written like this, and this is your count array. So initially all the counts are 0. You see, okay, give me the first bit, this is j equals to 0, and this is the first bit you extract. You see, okay, this bit is 1, so let's increment the count of 0 by 1. You see the next bit, it is 0, let's increment count by 0. You see this bit, in this case j is 2, let's increment the count by 1. Next time you again see one more 5, or you see 3, so 3 is like this, 1 1 0. So you update the count by 0, so it remains 1. So you see this bit, you update this count by 1. You see this bit, you update this count by 1, so it becomes 2. So you iterate on this using the while loop, and you update numbers, you update your sum of bits in the array at the same time. This is what we are doing here. Okay, so this way we do not need to store numbers, and once we are done, once we are out of the loop, we need to, let's say, print the array first. Okay, okay, let's iterate over the array, iterate over the array and reduce everything by mod 3. Okay, so let's do for int I equals to 0 and I less than 64, because maximum we can have 64 bits. We can say count of I mod equals to 3. So everything is reduced by a factor of 3. So once you do this, you will have a array like this. You will have a array like this form, right? And the next thing that you need to do now is, so you got this array, you converted this into a number like this 0 1 0, and now you want to make this into a decimal number, right? So you will make a decimal number. So you say, okay, I will multiply 0 with 2 raised to the power 0. I will add 1 multiplied by 2 raised to the power 1. This will give me 2. So we can take a variable p, which is 1, and we can generate powers of 2 as we go along in this direction. So let's see, and form the answer by converting zeros and ones into a number. So for that, we assume the initial power of 2 raised to the power 0 is 1, and next time we can say, okay, whatever answer is there, that is initially 0, answer plus equals to count of I, that is 0 or 1, the bit at the ith position after taking mod with 3, into the current power. And next time I can say power will be multiplied by a factor of 2. So p into 2, or you can say p left shift 1. That's it. And here we can print the final answer. Let's say cout answer handle. Okay, so let's compile the code and see. Okay, so one thing to note here is we are making an array of fixed size. So array of fixed size is always counted as a constant space. So this is O1 space, and we are not storing input anywhere. So this is O1 space actually in this question. Okay, because 64 size is constant, it does not depend upon the value of n. So it is like taking 64 variables. So your n can be anything, but your array size will always remain of 64. So yes, it is giving us the expected output. Now we can submit the code. Alright, so we have solved one more problem, and that's all for this video.